at the end we have to generate the family of circle. This is one of the important one type. From that one only we have a lot of previous year question. We need to design a one circle which is passing through the intersection of these two circles. Hello everyone, welcome back to Alan Overseas. Let's continue our special series. In the series we will cover 45 important topics in 45 days, which will really helpful to all JEE Mains aspirant. And the topic distributions are 15 physics, 15 chemistry and 15 maths. I am going to cover this section maths here. This is the study challenge we will do in the series. So without wasting too much time, so let's start with the topic, that is family of circle, which is under the chapter circle. You can see a lot of previous year question on the basis of this topic only. Let me clear you the things. Obviously we are going to start circle, that means you already have covered the straight line, in which you have like family. There's a family you already have learned, in which we have what? The behalf of family, we always have two lines, that is something like in this way. Now the intersecting point of these two lines we have, from that one we have one more line which is passing, and this is the concept of family of lines. Still I am going to stand my concept and I am going to apply the same concept behalf of circle. In the circle, the first type that we have is equation of the family of circles, which is passes through the point of intersection of two circles, S1 is equal to 0 and S2 is equal to 0. In short, I am going to assume two circles, that is something like S1 and S2. Now here what would be the scenario? Let's visualize the things. For example, two circles we have something like in this way. Now the point of intersection of these two circles we have here and here. Let's say this is A and B. Now according to the concept, we have number of circles, we can make many number of circles which is passing through these two point of intersection, like in this way, like in this way. So there are infinite circle we can design. Now the family of those circles, how we can represent? So the family of those circles we can represent with the help of the simple equation, that is S1 plus lambda S2 is equal to 0. Although we can assume S1, that is something like x square plus y square plus 2gx plus 2fy plus c is equal to 0. This is the equation of, let's say, S1. Now the S2 also you can represent x square plus y square 2g1x 2f1y plus c is equal to 0. Here we have what? This is like S2. Now try to visualize S1 plus lambda S2. When we are going to add these two equations with lambda, then we have what? X square plus lambda times of x square. In short, we have coefficient of x square, that is lambda plus 1. Similarly, the coefficient of y square, again we will get lambda plus 1, and so on. There is 2gx plus lambda times of 2g dash x. So kind of the things we will get after some time. But the thing which I want to tell you, that is why we are going to say you lambda, you are not allowed to put minus 1. You can see here. Here we cannot put lambda is equal to minus 1. If we put, then there is no x square and y square. That means no circle. That would be your radical axis, or you can say your linear equation straight line. But at the end we have to generate the family of circle. That means we have a requirement of x square, y square, and the coefficient of x square and y square would be the same. So for that one we cannot put lambda is equal to minus 1. This is the thing only you need to remember. Rest of the things are very easy. I am using the concept of family of line, which is L1 plus lambda L2 is equal to 0. And here in case of circle, S1 plus lambda S2 is equal to 0. I am using that one. This is your type 1. Now the next type 2, we have what? Equation of the family of circle passes through the point of intersection of a circle S is equal to 0 and a line L is equal to 0 is given by S plus lambda L is equal to 0. How? Try to visualize again. We have a one circle, that is something like in this way, and one more line like in this way. Now the point of intersection of these two, let's say this and this, A and B. Now here again we can make number of circle, those passing through A and B, and like in this way. So there are again infinite number of circles you can make. Now the equation how we can represent of those circles, we can represent with the help of, again there are one circle S, one more circle L. So you can represent that is like S plus lambda L is equal to 0. This is your L line and this is your S. So S plus lambda L is equal to 0 you can make. You will get again the family of those circles which satisfy this condition, and this is your type 2. Quite easy. Now the next type we have equation of a family of a circle touching a line L at its fixed point x1, y1 is. This is one of the important one type. From that one only we have a lot of previous year question. Here we have a one circle which is something like in this way, and a one line which is like in this way. Now they are touching each other here, right? So we have to generate the equation of a family of a circle who is touching a line at its fixed point x1, y1. So let's say this is a fixed point, that is something like x1, y1. Now the question is, how many circles you can make here which satisfy this condition? Still you can make many number of circles, that is something like in this way, like in this way, like in this way. Those who are passing through this, those who are touching this point, right? You can also make like in this way, like in this way. But here one more circle you can assume which is here only, that is point circle. In short, you can reducing your radius, then at the end there would be the radius which is negligible. So in that case you can assume that would be your point circle, and the point circle you have radius which is 0, you can assume, not exact 0, but yes it is negligible. That's why usually we have take the point circle, that is something like x minus x1 whole square, y minus y1 whole square is equal to 0, which is your point circle. And now with the help of this you can say S, this is your circle S, plus lambda L is equal to 0. Is still the same concept I am going to apply here. S plus lambda L is equal to 0. So with the first type, S1 plus lambda S2 is equal to 0. When we have two circles and those intersecting point we have, and we have number of circles which is passing through those intersecting point, we can represent with the help of S1 plus lambda S2 is equal to 0. Similarly, if you have a circle and a one line and those are intersecting at any particular 2 points you have, now again you can make family of circles which is passing through those intersecting point with the help of S plus lambda L is equal to 0. And the third one, the point circle. In the point circle, radius would be 0, is still the same concept, S plus lambda L is equal to 0. So still you have to apply the same concept always. If you have line, if you have circle, if circle, then circle S1 plus lambda S2 is equal to 0. If line and circle, so S plus lambda L is equal to 0. If there is point circle, so the change is only the radius will become 0. Still same concept. Now it's time to apply your concept. Now it's time to apply our concept in one previous year question. The question is, the circle passing through the intersection of the circles, this, and having its center on the line, this line, also passes through the point, and this is from 2020, right? So now, first of all, the concept is simple. We need to design a one circle which is passing through the intersection of these two circles. That means these two circles we have, and the intersecting point of a circle, new circle, will passes through these two intersecting points, that is A and B. And we know how to design the equation of such circle. We can design S1 plus lambda S2 is equal to 0. You know, S1 we have x square plus y square minus 6x plus lambda times of s2 x square plus y square minus 4y is equal to 0. You know, here you can simply take x square as a common, then you have lambda plus 1 lambda plus 1. Now y square you can take common, again you have lambda plus 1, minus 6x is there, and then minus 4y lambda is there. Now obviously, as usual, we have to make the coefficient of x square y square same. So for this point of view, I am going to divide this complete equation with lambda plus 1. You will get x square plus y square minus 6x and then minus 6 upon lambda plus 1 into x minus 4 upon lambda plus 1, but there is also lambda, y is equal to 0. Now here this is, let's say, equation number 1 you have. Now what I want exact equation, and apart from this we should have an idea about the lambda. But for this, before this, I want center. So the center you can design very easily. Center you will get 3 upon lambda plus 1 while dividing with minus 2. Again you will get here 2 lambda upon lambda plus 1. You know, this center according to this question is lie on this line 2x minus 3y plus 12 is equal to 0. You can satisfy here. So twice of 3 upon lambda plus 1 minus 3 2 lambda upon lambda plus 1 plus 12 is equal to 0. What I am doing here, according to this question, this center must be lie on this line. So that means it must be satisfied, and I am going to satisfy here. Now you need to solve this simple equation, then you will get 6 upon lambda plus 1 minus 6 lambda upon lambda plus 1 plus 12 is equal to 0. Now after getting the LCM, you will get 6 minus 6 lambda plus 12 lambda plus 12 is equal to 0. You can solve this, you will get 6 lambda and then minus 18, that means lambda is equal to minus 3 you have. Now you need to put this here. Either it's better to put here directly in equation number 1, because I want the exact equation of circle. So you can put in equation number 1, then you will get, when I am going to put lambda is equal to minus 3, you will get x square plus y square. You can put here lambda is equal to minus 3, then minus 3 plus 1, here is minus 2, then you will get plus 3x. Similarly, minus 3 plus 1 minus 2, there you will get minus 2 lambda, then plus 2 lambda. But because of lambda we have minus 3, so you will get minus 6 and then y is equal to 0. You know, you have equation x square plus y square plus 3x minus 6y is equal to 0. But at the end, what we need to find? We need to find it also passes through the point. So that means if we take x as a common from this and this, then you will get x plus 3. Similarly, y you can take common, then you will get y minus 6 is equal to 0. From this, it is quite easy to collect those points which is satisfying this equation. That is minus 3 and 6, which is in option number B. Either you can satisfy here. So this is the simple way to do such type of question from family of circle. So that's all from my side on this topic. Don't forget to watch the complete series. The playlist link is available in description box. Still, if you have any query or any suggestion, feel free to reach out to us through the comment section. For more, stay tuned with us. Thank you.